Welcome to the DIY Honda Garage channel. The DTC code P2564 specifically refers to an issue with the Turbocharger Wastegate control actuator position sensor circuit. This error code indicates that the output voltage from the Turbocharger Wastegate control actuator position sensor is lower than a specified threshold, prompting the Powertrain Control Module, PCM, to recognize this as an abnormality. The Turbocharger Wastegate control actuator position sensor plays a crucial role in regulating the turbocharger's wastegate operation, which directly influences engine performance and efficiency. It is usually integrated with the turbocharger unit itself, located in the engine compartment. When the PCM detects low voltage from this sensor, it triggers the diagnostic trouble code P2564, which signifies a need for thorough inspection of both the sensor and associated electrical components. The Turbocharger Wastegate control actuator is essential for managing the turbocharger's boost levels in conjunction with the position sensor. This actuator adjusts how much exhaust gas bypasses the turbocharger, thereby controlling the boost pressure in the engine. The position sensor specifically monitors the actuator's position and sends voltage signals back to the PCM. When the voltage is deemed low, it suggests a malfunction in the control circuit or within the actuator itself. The location of the Turbocharger Wastegate control actuator position sensor is integrated within the turbocharger assembly in the engine compartment, making it relatively accessible for inspection. Understanding the roles of these components is critical for diagnosing the DTC P2564 effectively. There are several potential causes for the DTC P2564. First, the Turbocharger Wastegate control actuator may be faulty, leading to improper functioning and low voltage readings. This could stem from wear, mechanical failure, or other internal issues within the actuator itself. Second, there could be damage to the external circuits, specifically the VCC2 and DCWGL circuits, which connect to the actuator and the PCM. These circuits must be intact for proper communication and operation. Finally, a malfunctioning Powertrain Control Module, PCM, itself could also falsely report low voltage, meaning it erroneously interprets the signals it receives from the sensor. Each of these causes prioritizes the need for systematic inspection and testing for a proper diagnosis. The symptoms associated with DTC P2564 can significantly affect vehicle performance. One of the most noticeable symptoms is reduced engine performance, as the turbocharger may not function efficiently due to improper wastegate control. Additionally, you may notice issues with turbocharger inefficiency, which can lead to noticeable delays in acceleration and a lack of power under load. This may manifest as turbo lag during driving. Furthermore, the vehicle's check engine light is likely to illuminate on the dashboard, alerting the driver to a malfunction related to the turbocharger system. Each symptom reinforces the importance of addressing the DTC promptly to prevent further engine complications and maintain optimal driving performance. The first step in troubleshooting DTC P2564 involves setting the vehicle to the on mode. This preliminary action is essential to engage the vehicle's electronic systems for testing. Next, using the HDS or Honda Diagnostic System, check the voltage from the lift sensor for the electric wastegate, EWG. If this reading is less than 0.16 volts, it confirms that the failure has duplicated, indicating that further investigation of the circuit or component is necessary. It's critical at this stage to ensure that no other faults are present that could skew the testing results. For clarity, the HDS is a sophisticated tool used for diagnostics in Honda vehicles, making the observing of sensor values straightforward and accurate. In this second troubleshooting step, the focus is on the turbocharger's 5P connector. Begin by disconnecting the turbocharger connector, isolating the component for an accurate inspection. The goal is to assess the output voltage at this connector while in IG mode. This is typically performed with the ignition set to the on position. Under normal conditions, the output voltage should be approximately 5.0 volts. If the reading is normal, it suggests that the turbocharger actuator itself may be the source of the issue. Conversely, if the voltage is lower or non-existent, it indicates a problem with other related components, such as the electrical circuitry leading to the actuator or the PCM itself. This systematic approach ensures that all potential fault sources are investigated thoroughly. The third step involves comprehensive circuit inspections concerning the VCC2 and DCWGL circuits. Before starting, ensure that the PCM connector is also disconnected to avoid any electrical shorts during testing. In IG mode, check if the VCC2 circuit has any open wire conditions. Ideally, it should show less than 1 ohm resistance. If this resistance is significantly higher or open, there is an issue in the circuit that can prevent proper voltage supply to the turbocharger actuator. Also, inspect the DCWGL circuit to confirm that it is not shorted to ground. A short in this circuit could falsely influence the readings, further complicating diagnostics. Identifying issues in these crucial circuits is essential to resolving the DTC effectively. In the final step of troubleshooting for DTC P2564, the focus shifts to the powertrain control module, PCM itself. If all previous inspection items and tests have returned normal values, it indicates that the PCM may be at fault. The PCM is a pivotal component that governs numerous systems within the vehicle, interpreting and managing data from various sensors. It is crucial to confirm that no other components are causing the abnormal conditions observed. Once verified, if the PCM appears to be malfunctioning, this could either require repair or replacement. Given the complexity of modern electronic systems, accurate diagnostics is vital to avoid unnecessary parts replacement. After completing all repairs and replacements related to DTC P2564, it is crucial to conduct a final verification process. Begin by clearing the DTC from the Powertrain Control Module, PCM, using the Honda Diagnostic System, HDS. Following this, it is essential to carry out a road test under varied driving conditions to confirm that the original symptoms do not reappear. During the test drive, monitor the vehicle's performance closely, paying attention to any anomalies that could indicate unresolved issues. If successfully passing without the reappearance of the DTC or any related symptoms, you can conclude that the repairs were effective. This verification process is significant in ensuring both the reliability and performance of the vehicle post-repair. To prevent the recurrence of DTC P2564, regular preventive maintenance should be implemented. Routine tune-ups are essential to ensure that the vehicle's engine and turbocharger systems are operating efficiently. This includes checking not only the actuator, but also related components such as hoses and sensors for wear and tear. Furthermore, periodic inspections of the turbocharger system can identify potential issues before they escalate into significant faults. It's also a good practice to keep the PCM software updated, as manufacturers often release updates that can improve performance and reliability. Adopting these maintenance measures can enhance longevity and performance, significantly reducing the likelihood of future trouble codes. In conclusion, understanding DTC P2564 and its implications on the turbocharger wastegate control actuator position sensor circuit is essential for proper vehicle maintenance. A thorough inspection process allows technicians to effectively diagnose the root causes of the issue, whether they lie in the actuator, the electrical circuits, or even the PCM itself. The outlined troubleshooting steps provide a systematic approach to addressing the problem, ensuring that every potential source of failure is examined. Lastly, implementing preventive maintenance measures can help maintain the overall health of the vehicle, promoting longevity and optimal performance. Being proactive in vehicle care will not only enhance driving experiences, but also ultimately save on potentially costly repairs in the future. Please like and subscribe to the channel. See you next time.